Right. In this video, we are going to talk about the function of a thermistor, right? Sorry, not about the function of a thermistor, what we can do with a thermistor, right? So we can use thermistors to design fire alarms, and we already know the function of a thermistor. So let me recall it, right? As I told you, for a thermistor, what we call NTC thermistor, that is a thermistor which is in our syllabus. So for NTC thermistors, when the temperature goes down, goes up, right, the resistance decreases. That's what I told you. When the temperature goes up, the resistance goes down. So here I have given a circuit, right? The EMF of the battery is E, you can see it here, and the resistance of the resistor is given here. It is R1, and resistance of the thermistor is R2. The potential difference across the resistor is V1, and the potential difference across the thermistor is V2, right? And you already know this equation. The E can be written as V1 plus V2, because I told you the cell is the energy supplier here, and he's providing energy, and the resistor and the thermistor, they are energy consumers. So they will consume the energy supplied by the battery. So at the end, they should be equal, right? Now, let's imagine a scenario like this. Now, we are going to arrange this circuit, right? Or design this circuit where V1 is now not enough to power the bell, right? V1 is not enough to power the bell, right? So if the V1 is not enough to power the bell, even when you supply current or the power supply as the way which is given in the circuit, and you don't get any sound from the bell. Why? Because V1 is not enough to power the bell, right? Okay, right. So I'll write initially V1 is not enough to uh, ring the bell. But what will happen during a fire, right? So you already know, during a fire, temperature increases. During a fire, what will happen to the temperature? Temperature increases. Okay. Then you already know this equation, which I'm going to write now, right? Here I can write V1 over V2 is equal to R1 over R2, right? You're already familiar with this equation, right? Okay, just keep this on in your mind, right? We need this one. Okay, then V1 over V2 is equal to R1 over R2. And during a fire, as I told you, temperature increases. If the temperature increases, then what will happen to the resistance of the thermistor? It will decrease. Resistance of the thermistor will decrease, which means R2 will decrease. Now you can take it like this. Here, before the fire, right? Let's imagine the resistance R1 is 5 and R2 also 5. So you get 5 over 5, which is equal to 1. But during a fire, as you already know, R2 decreases, right? So let's get, here it is 5. Let's imagine the resistance goes to 1. Then you will get what? 5, which means this number over here, the number which gives by this fraction, will increase, right? You can see before it was 1, and during the fire it is 5. Then now we have an equation, so you already know that if this number, if the right hand side increases during a fire, so the left hand side, right? So for an equation, if the right hand side increases, left hand side also should increase. In this case, right? So if this number increases, then V1 should increase. Is it clear? Now V1 should increase to get a higher number, like the same number as this one, right? Okay. Before it was 1, now it is 5 during a fire. So to increase the number in the left hand side of the equation, the number gives by the fraction in the left hand side of the equation should increase, right? Therefore V1 should increase. Then what will happen? There will be what? Enough voltage to ring the bell, right? There will be enough voltage to ring the bell. So you can write here, right? Therefore, right? So V1 will increase, then there will be enough potential difference to ring the bell. Right? There will be enough potential difference to ring the bell. Right? Now you might argue, if you are good at math, right? Then you might argue, so if now I know you are familiar with this case, right? Let's imagine a case like this. Now, if you are telling me, so okay, we want to increase a number here. So why can't V2 get decreased? And we can still get the same number, right? Even V2 is decreased, right, in the right-hand side, then this number will increase. Why can't that happen? Okay, right? That's why we need this equation. Now you know what E, which is the EMF, it is a constant. EMF is constant. So if V2 decreases according to you, then what should happen? V1 should increase, right? If V2 decrease, V1 should increase because E is a constant. Either way, what? The potential difference across the resistor, which is the potential difference across the bell as well, it will increase. So there will be enough potential difference for the bell to get ring, right? So we can decide fire alarms by using thermistors.